Hello everyone, today we're going to do 10.3.1 and this lesson is about looking at the differences between an intercept or an intersect. Right? I know those two words sound very similar, but they have entirely different meanings. We're going to take a look at two different functions and identify what those two differences are. All right, so let's just read the first paragraph here. It says, now that you know about several families of functions, you will look more closely at intercepts and intersections. What is the difference between an intercept and a point of intersection? Think about this as you develop algebraic methods to find points where two functions cross. In the next few lessons, you will have chances to practice your quadratic solving skills as well as your newer solving skills from this chapter. So taking a look at 10-97 here, they give you two different equations, a quadratic and a linear, right? And they actually graphed it for you. So they give you two different graphs, or it's the exact same graph, but one is through Desmos, the one on the left, and where it's a little bit more interactive. One on the right is just like a pre-printed one. So we're going to take a look at the one on the right for now, because I want to answer questions A, B, C, and D, or I want you to answer it. So I want you guys to pause the video and answer all four of these questions with either graphs that you want, and come back when you think you know the answers to these questions. Okay, so just read these on your own and try to do the best you can. All right, let's go through question A real quickly. Name the all x and y intercepts for the parabola. So an intercept for the parabola, we're going to be looking at the x-intercepts and the y-intercept. Right? So in other words, where do they hit the x-axis? Where do they hit the y-axis? So for the parabola, right there, I have two x-intercepts. I have, the first one is negative 2, 0. The next one is 5, 0. Right? And then I also have the y-intercept right there, and that is 0, negative 10. And then for question B, it says find the x and y intercepts for the line. So let's take a look at that line that's provided. I have 2 points right there. I have a y-intercept of 0, 2, and then an x-intercept of 1, 0. Then question C says, where do the graphs intersect each other? Or intersect, you think of it as the streets, two streets crossing, it's called an intersection, right? So it intersects, where do the two graphs cross, or those blue points right there. And the first one on the top left is going to be negative 3, 8. And then the second one, it's going to be 4, negative 6. And those are where the two graphs intersect each other. So answering question D, the words intersect and intercept look and sound a lot alike, but what do they mean? How are they the same? How are they different? So it does have to do, they're the same because they do cross certain points that you're looking for, right? Special points. So if you look at the intercept, where I have them in the red, purple, and green, those are where they intercept the x and y axes, right? And then how is that different from an intercept? Well, an intersect, that's where the two lines intersect and cross each other. Okay, so that's the blue points. So one crosses the axes, the other one, the graph, crosses each other. Okay, so the intercepts cross the axes, the intersect crosses each other. Hopefully that made sense. All right, going to problem 10-98. Says intercepts and intersections are similar, but they are not exactly the same. How can you tell which one you're looking for? Read the situations below and decide if the graphical solution would be best represented as an intercept or as an intersection. Be prepared to defend your decision. You don't need to solve this problem. Okay, you just you're going to tell me with the three scenarios provided, which one is going to be an intercept, which one is going to be an intersection, and say why. Okay, so pause the video and come back when you have all three of these done, A, B, and C. Okay, so for first situation, we've got a 5-gram candle on a birthday cake that is lit. And then after 2 minutes after it's lit, the candle now weighs 4.2 grams. How long will the candle burn? So in essence, this situation, we have a candle that weighs 5 grams, and as time goes by, it's decreasing, right? And eventually it's going to reach 0 and there's no more candle remaining. And therefore, this is going to be an intercept. Not sect, intercept. So it's going to hit it's going to give me an x-intercept, right? When it reaches 0. Okay, so for problem B, bowling alley charges you $4 to rent shoes and $3.50 a game. Another alley charges you $7 to rent shoes and $2 per game. How long do you need to play in order for both alleys to charge you the same amount? This is a classic linear systems equation. One is going to charge you a certain rate, but has the initial charge a little bit less. So this could be $4 to rent the shoes. The next one could be $7 to rent the shoes, but charges you less. And so, in other words, they're trying to find when they cost the same, which is at that point, which is going to be an intersection. Oops, I can't spell. So that's going to be an intersect. Okay? And then the last situation, very similar to question B, 2 months after Aaliyah's birthday, she had $450, while her sister Claudia had $630. 5 months after her birthday, Aaliyah had $800, while Claudia had $920, right? So at first glance, one may think that, well, this is probably going to be like situation B, where we're looking when they're going to have the same amount, right? But that's not the question. The question is, how much did each person have on Aaliyah's birthday? So if we were to go back to create a graph, Aaliyah had 450, right? And then Claudia had 920. And they're both saving, and eventually they're going to have the same amount, right? Or excuse me, she had 630, not 920. I'm reading it wrong. So eventually they're going to have the same amount, but that's not the question. The question is, how much did they have on Aaliyah's birthday? So on Aaliyah's birthday is the starting point right here. If that's her starting point, that's where x equals 0, and in essence, that's the y-intercept. Yes, intercept. Whew. Had to think there for a minute. Okay, so situation A is an intercept, B is an intersection, which we call an intersect, and then C is an intercept, because they're asking you how much money did they have on Aaliyah's birthday. At the very beginning, we're looking for intercepts. All right, hopefully that clarified the differences between the two. Okay, let's move to the next one, 10-99. It says, using your graph to find the intersection of two curves can be challenging when the point of intersection is not on grid lines or ends up off the graph. Therefore, it helps to know another way to find the intersection without using your graph. Name the algebraic model, as you already know how to solve linear systems. Right? So there are a few different ways we've done it algebraically. We've done it through elimination. We've done it through substitution, which substitution is basically just another way to do equal values method. Okay. So for part B, it says use one of the methods that I just mentioned to solve that quadratic equation right here. Y equals x squared minus 3x minus 10, and this linear equation of y equals negative 2x plus 2. Okay, so it says to carefully record your steps. Be sure to collaborate with your teammates. Obviously, you can't collaborate with anyone. And then ask yourself, does a graph in that first problem that we did today, 10-97, confirm your results? So go ahead and try to solve this linear system, okay? Or excuse me, not a linear system, it's a quadratic and linear system together. So how will we solve for x if I have two different equations? And again, you can use elimination, equal values method, substitution. You got to kind of dig back into your toolbox and remember how to do this. So take as much time as you need and solve that system, and pause the video, come back when you're done. Alright, so hopefully you guys use the same method I did. You didn't have to, but this is probably the most straightforward method. It's the equal values method. Since they both of those equations equal y, you're saying y is obviously equal to y, so therefore whatever y equals on this equation is going to be the same as whatever y equals on that equation. So in essence, we're setting those two equal to each other, and we get this. This is the setup right there. Negative 2x plus 2 equals x squared minus 3x minus 10. So you're going to bring everything to the side of where the x squared term is, because that's the only term that you can't really get rid of. So we subtract 2x on both sides, and then we subtract 2 on both sides, right? And my new trinomial is going to be x squared minus x minus 12, and that is easily factorable into an x minus 4 times an x plus 3. And using the equal values method, I get x equals 4 and x equals a negative 3. So the question is, well, if we're comparing that to what we got in our graph that was given to us when we started off today's lesson, does it make sense? Well, if x equals 4 and x equals 3, well, remember, when we're solving two equations, one is a parabola, right, and one is a line. The solution is where the two graphs intersect. Well, do they intersect at 4 and 3? Well, kinda. You know, if you think about it, what did we just solve for? We didn't solve for x, or did we solve for y? We technically solve for x. So our 2 points of intersections have x values of 4 and 3, or excuse me, negative 3, right? What's the y value going to be? Well, we can figure that out easily by plugging our x values into our equations for x and solving for y. And you'd have to do that 2 times, and you would get your answer. So if x equals 4 and x equals negative 3, does that make sense? Well, let's go back to the graph that's provided here. X equals a negative 3. So remember, this is our point of intersection here. That is going to be negative 3 comma something, right? Now we can easily count this, and this is going to be a comma 8. The next one is x equals positive 4 comma something, and again, looking at the graph, it's going to be a negative 6. But if we plug that x value into those two equations, both of those x values, we're going to get an 8 when we plug in a negative 3, and we're going to get a negative 6 when we plug in a positive 4, just like the graph shows here. All right, so hopefully that made sense to you guys. Let's look at 10-100. I want you guys to do the same thing now and solve this on your own. And if you want to graph it with a graphing calculator to confirm your solution, please do. Okay, so solve this equation for 10-100. All right, so bear with me here. This is where I've started, right there. Okay, I set them equal to each other using the equal values method. So this one's a little bit tricky if you're not too comfortable or too familiar with how to get rid of that x in the denominator on the left side. You're going to have to multiply both sides by x, and that will cancel with the x in the denominator. That means on the right side I must distribute my x, and I get 2x squared plus x, bring the negative 1 over, and I get this trinomial. From that trinomial, I felt like switching things up a bit, and I used a quadratic formula, and I solved, and I got x equals negative 1, or x equals 1/2. So what did I do with that? I plugged it in over here, and I chose just one equation to plug it back into. And you can choose any equation you want. I happen to choose this one because I didn't want to mess with that x in the denominator. You could have easily chosen a 1 above it and gotten the same answer, right? So when I plugged in 1/2, my final answer is, for y is 2. So the intersection of those two graphs is at 1/2 comma 2. And when I plugged in a -1 in for x, I got an answer of y equals -1. So the other point of intersection is -1 comma 1. All right, so at this point we're going to skip, excuse me, we're going to skip 101. You know what? No, let's do 101, and then we'll do one more after that. So I want you guys to attempt 101 on your own. Pause the video, come back when you're done. I'm not going to spend too much time going over it, but I'm just going to give you guys the solution to that. Okay? So attempt that video, or attempt that problem, and pause the video and come back when you're done. Alright, so at this point, again, equal values method or substitution, however you want to look at it. I set this equation up, and I started to get all the terms to my right side by subtracting x and subtracting 1, and this is my new trinomial. And that trinomial looks like it would be easily factorable, but it's actually not factorable, right? Because nothing times another number will equal 4, but adds up to 3. So that's not going to work. So some of you guys might give up after you find out that it's not factorable. But it doesn't, just because it's not factorable doesn't mean that there's not a viable answer, right? It could have decimals, it could have fractions. So the next thing you want to do is you want to use a quadratic formula, because that will always give you an answer no matter what, right? So the situation here is when I plug it into the quadratic formula, I have a square root of a negative number as my final answer. And because of that, I know the answer is going to involve an imaginary number, and therefore we are not going to have a solution here. All right, so no solutions. These graphs will not cross. Hopefully that made some sense. All right, last problem of the day, we're going to go to 10-104. And again, same thing, more practice. Hopefully you guys are going to get good at this. Solve this system here for x and for y. Okay, and if you want to use decimals to check your solution, go for it. But pause the video and come back when you're done. All right, so here's a fun one. Again, we're going to set this up through equal values method. We're going to get this equation right there, and we're going to isolate everything, bring it over to the right side, and our new trinomial is going to be right there. And because it's decimals, it's going to get pretty ugly, so I'm opting not to try to factor it because that's going to drive me crazy. So I'm just going to use the quadratic formula, and using the quadratic formula, I end up with the square root of 2.56 right there, which is a perfect square root. Square root of 2.56 is 1.6. So I'm going to get two different answers. Negative 0.6 plus 1.6 is going to give me 1, and then I put it over 2, which is a half. And then if I do the same thing, negative 0.6 minus 1.6, I'm going to get negative 2.2 divided by 2 is negative 1.1. I'm going to take that, plug it into my two equations. The same equation, just do it two different times, once for each variable, and I'm going to get my y values. So again, I chose the easier equation to plug it back into. I'm not going to plug it back into that quadratic equation because it would be a lot more work. So my answer is 1/2 comma 2 and negative 1.1 comma negative 1.2, and those are where my two graphs will intersect. All right, again, if you want to check that on Desmos, feel free to, but that's going to be a wrap for today, guys. Thank you for your time. Hopefully you guys have a better understanding of what an intercept and an intersect is. Maybe write that down as your closing statement for today's lesson. And as always, come to our Google Meets if you have questions, or set up an appointment with me on Calendly. And I hope you guys have a great day. I'll talk to you soon.